Okay, hi everyone. So in this example, we actually have an integral where we are required to integrate the function of x squared sine x from the range of 0 to pi, and to show that that value is equals to pi squared minus 4. Looking at this integration, we can't use the substitution rule, because in this case sine x is not sine x cubed. If it was, you'll find that the substitution rule would work. But in many cases, when you actually have two functions, a product of two functions like this, it's a likelihood that you actually need to do integration by parts. Okay, initially I would like to talk a bit about the integration by parts formula. It actually comes from your product rule. So if you have two functions u and v, both which are functions of x, and you differentiate it with reference to x, you actually have u dv per dx plus v du per dx. Okay, that's your product rule. And we can actually get it in the form of duv equals to u dv plus v du. Okay, so the usual form of integration by parts, we actually will look either v du or u dv. So let me make u dv as the main part, and we actually want to look at the integral of this. So u dv would then be equals to integral of duv, okay, minus integral of v du. So in this case of integral of duv, so this will just return back uv, and this part here will be v du. So this is the form of integration by parts. Okay, the other thing to mention that's important in order to solve functions like these by integration by parts is to remember the rule of Liate, L-I-A-T-E. Okay, so there are abbreviations for logarithm, so the inverse trigonometric function, A, algebraic functions, trigonometry, and also E will be exponential functions. So basically you would follow by the one being the last, that would actually go and be replaced as dv, or that part will be represented by dv. Okay, what do I mean by that in this function? So let us look at it. So we actually have integral of x squared sine x dx. So what I mean by looking at the Liate, so I identify that this is actually an algebraic function, okay, while this is the trigonometric function. So as you can see, t comes after a, so means that I will actually represent this function as dv, while that x squared I will represent it as u. So therefore, let me write it over here. So u becomes x squared, while dv becomes sine x delta x. So we need to fulfill the part of the parts of the components for the integration by parts. So therefore, we need to get du per dx in this case, which is equals to 2x, or du equals to 2x dx. And for this, the v will be the integral of sine x, that will give us negative cos x. Okay, and having all these components, we then incorporate it into the integration by parts. So integral of u dv, which is going to be that x squared, which is u, so dv is sine x dx, that will be equals to, so now as we see the formula, uv, so u as we see it is x squared, v is negative cos x, okay, minus the integral of v, which is negative cos x, and du, which is going to be 2x dx, Okay, so we actually have negative x squared cos x plus 2 integral of x cos x delta x. Okay, so we see that we again arise at the situation that we may require integration by parts. So what I need to do is, based on Lie again, I identify this as the algebraic function, while this is trigonometric function. So let's just look at this integral of x cos x and use the same principle of integration by parts as I've shown earlier in this, but with reference to this x cos x. So what happens is this then becomes x sine x, okay, because we integrate cos x, that becomes sine x, minus the integral of sine x, and that part which was x which we differentiate, so that becomes 1, so this then becomes just dx. Okay, so what happens is we then find that the integral of x squared sine x dx would then be equivalent to negative x squared cos x plus 2 x sine x minus, so integral of sine x is negative cos x, so I can put this as plus cos x. Okay, and what we're going to do now is, because we're going to integrate it from 0 to pi, so we're going to actually substitute 0 to pi in this function. So if we were to look at it, what happens is this becomes negative pi squared. So cos pi is negative 1. So plus 2 times, okay, so sine pi, that will be equals to 0. So therefore this term becomes 0. So 2 times 0. And then cos pi. So this becomes, cos pi is negative 1. So therefore this becomes negative 1. So that part becomes negative 2. Okay, and then this will be minus. Okay, so 0 here. So x squared, which is 0 squared, that would actually render this this part of the function 0. Again, x sine x, so x 0. So that will again will be 0. Cos 0 is actually equals to 1. So therefore this becomes 2. That remains. So therefore, as we can see here, the final answer that we get is, so negative pi squared times negative 1. This becomes pi squared. Negative 2 minus 2. This becomes minus 4.